Greetings, welcome to APchemistrycourse. In today's lesson I'm going to talk about Boyle's law by solving easy questions. So we're going to solve 3 different levels: easy, medium and hard, and might go to an expert level. Alright, so let's start solving the questions. So the first question says or states a gas occupies 12.3 liters at a pressure of 40 millimeters of mercury. What is the volume when pressure is increased to 60 millimeters of mercury? Alright, so I want you to just get a piece of paper and write down the question again, and write each question and answer it. Alright, again, a gas occupies 12.3 liters at a pressure of 40 millimeters of mercury. What is the volume when pressure is increased to 60 millimeters of mercury? Alright, so if you watch the old video of Boyle's law, I gave the formula or the equation that we used to solve the question. So what was it again? You're right. So the question or the formula, the equation that we need to use is P1 times V1 equals P2 times V2. What happens here is that, as you can tell from the P and the V, P stands for pressure, V for volume. The first pressure and the first volume, or the initial pressure and the initial volume, and then here the final pressure and the final volume. Alright, let's use that formula to solve the question. Well, it's going to be an easy question and a simple question, so let's start. They say that a gas occupies 12.3 liters. So it occupies, or it started at 12.3 liters. That's a good key that we need to use. Alright, so we write the first pressure as 12.3 liters multiplied by V1. Now at a pressure of 40 millimeters of mercury. Alright, so it states here that the volume is 40.0 millimeters of mercury. It's not the pressure, okay? So the volume is 12.3 liters, and the pressure is written as 40 millimeters of mercury. So we're going to write down 40.0 millimeters of mercury. Alright, again, just for the people who didn't notice that 12.3 is the volume. I mistakenly wrote it in the pressure side. Alright, so the pressure is 40 millimeters of mercury, so it's 40, and the volume is 12. We are an equal sign, and we continue reading. It says, what is the volume when pressure is increased to 60 millimeters of mercury? So they're saying that the pressure has increased. Well, if the pressure increased, then we're left with volume, as they said. What is the volume? They want to know. So what we write down is that we write 60 millimeters of mercury multiplied by the symbol of the volume, V2, the final volume. Alright, so we know first pressure, first volume, second pressure, but we don't know the second volume. How can we solve that? We can solve that algebraically. So what can we do is that we need to leave V2 on one side. How can we do that? We divide simply 60.0 millimeters of mercury on both sides, and then this cancels this. Unit cancels unit, millimeters of mercury cancels millimeters of mercury, because as we know in conversion units, when the units are similar up and down, they cancel each other. We're left with the unit L, liters. Alright, let's do the math right now. So simply, you can grab a calculator just to not waste time, or you can do that mentally. Alright, so we write 40.0 multiplied by 12.3. Divide that by 60.0, that will equal to 8.2. Alright, so we write V2 equals 8.2 liters. Alright, so that's going to be the new volume that we are going the VF that we have right now. Alright, so as you can see that there's a problem. We have 3 significant figures here. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So the answer is 8.2. Is that correct? No, because the question here mentions that we need to write the answer only in that question in significant figures. Well, I did that on purpose just because to let you understand that when you're doing chemistry, significant figures are really important, and I have a video about them. You can go back to the channel and check the video out. Alright, so in the other questions, let's leave the significant figures alone, so it can be simple math. Alright, and when we go to the medium level, we're going to start using the significant figures. Alright, so the answer is going to be 8.20 liters. Alright, so we got the V2, great. Now let's go for the second question. Now the second question states that if a gas at 25 Celsius occupies 3.6 or 3.60 liters at a pressure of 1 atm, the atmospheric pressure, and what will be its volume at a pressure of 2.50 atm? Alright, great. That's a great question, but I would like you to solve it by yourself. Alright, so start solving. Let me repeat the question for you. You can write it down. Alright, the question says, if a gas at 25.0 Celsius occupies 3.60 liters, okay, at a pressure of 1 atm, what will be its volume at a pressure of 2.50 atm? Alright, great. I'll give you time and solve it. You're done. Great. Let me check your question, or let's check your question. Alright, so the question states, if a gas at 25 Celsius. Alright, some of you might notice the word Celsius. And we're talking about pressure and volume. There's no T in that equation, like when we're talking about pressure and volume relationship. We don't have no temperature. You're right, there is no temperature, so the unit of the temperature is just a trick that is used by the book or by the question to trick you and let you use it without you noticing. Alright, great that you guys didn't fall for it. Alright, so we ignore 25 Celsius and we go for 3.60 liters. So that is the volume. The first volume that we started with is 3.60 liters. Alright, so pressure is aside, then 3.60 liters used. Alright, now at a pressure of 1 atm, so they're saying that the 3.60 liters, or the volume, has a pressure of 1 atm, 1.0 atm. That equals to P2 times V2. We can see that what the question says, what will be its volume? So we're missing V2. At a pressure of 2.50 atm, so we write down 2.50 atm. Great. So we multiply that by V2, the unknown. Whenever they say what will be its volume, that means what is the new volume, or the V2. And if they say what will be its pressure, so that means they're searching for pressure. A simple way just to understand it. Alright, so we start doing the algebraic equation. We want to keep V2 aside so we can know what is V2. So we write 2.50 atm divided by 2.50 atm. This cancels this out and we're left with V2. Alright, let's do the math using the calculator and let's check the answer. So it says that we have 1 atm, so 1 atm multiplied by 3.60 divided by 2.50. Well, if you do the math right and you get the calculator, the answer is going to be 1.44. What are the units? ATM cancels ATM out, we're left with liters. So that's the answer. 1.44 liters. That is our answer for V2. Alright, we answered till now 2 questions. Now let's go for more questions to solve. Alright. So, the next question is going to be it. Alright, now we're going to go for the third question. Alright, so the third question says that a gas occupies 11.2 liters at 0.860 atm. What will be the pressure if the volume becomes 15.0 liters? Now I want you to look at the line that I put and the box that the sentence that I boxed. So what happens here? Why did I do that? Well, simply because it says what will be the pressure. So that shows the question. What will be the pressure? That means we're searching for a pressure. Then if the volume becomes, so that means if the volume, that means the volume is given, and the pressure is the one that is we're trying to solve. Alright, so I'll start solving. So I would like to write down the question. A gas occupies 11.2 liters at a 0.860 atm. What will be the pressure if the volume becomes 15.0 liters? Now I want you just to try and solve that question, and when you're done, continue watching the video. Alright, great, you're done. So that's going to be a positive thing, and I hope that you answered it correctly, the question. Alright, so let's start solving. So a gas occupies 11.2 liters. That's going to be the V1, the volume. Alright, so we write multiply. Wait, let's switch. That's going to be the volume, which is going to be 11.2 liters. Alright, great. And at 0.860 atm, that's going to be the pressure. 0.860 atm. Nice, nice. That will equal to the unknown pressure, which is going to be P2 written, and then multiplied by the new volume, which is going to be 15.0 liters. Alright, so let's solve that algebraically. So we're going to do that algebraic expression, and we're going to divide on both sides with 15.0 liters in both sides. But why is that? Because we want pressure by itself so we can know the answer. So we're going to leave pressure by itself by just dividing both sides by 15.0 liters. So this cancels this out, and we're left with P2. Let's do the question using calculator because we don't want to waste time. Alright, so just write down 0.860 multiplied by 11.2 divided by 15.0, and I will equal to that's going to be an answer of 0.642. 0.642. What's going to be the units? We have liters and liters. They're going to cancel each other, and we're left with atm. So we're going to have 0.642 atm. That's going to be our new pressure. Alright, for the people who are wondering, why did the pressure decrease instead of increase? Well, it's a simple answer. Simply, if you look at it in a physical way, we have a box that the volume is only 11.2 liters, so that's an 11.2 liters. We have here the air particles, and the pressure is 0.860 atm. Now simply what happened here is that we took the same particles and we put them into a larger box, which can contain or can hold, which is going to hold 15.0 liters. What happens here is that if we go at Boyles law and we look at it, it says that as volume increases, pressure decreases, and as volume decreases, pressure increases. So what happens here is that we're going to have the new pressure of 0.64 to atm because we went from small volume to a larger volume. So we're applying to Boyles law, and the pressure will decrease. Alright, so that's for the first question. The third question, and let's go for the fourth question. So for the fourth question, it says that 500 milliliters of gas is collected at 745.0 millimeters of mercury. What will be the volume be if the pressure becomes 900.0 millimeters of mercury? Alright, I would like to solve it by myself, and pause the video. I'll reread the question and start solving. The question states 500 milliliters of a gas is collected at 745.0 millimeters of mercury. What will be the volume be if the pressure becomes 900.0 millimeters of mercury? Alright, take your time, solve, pause the video, and when you're done, you can check your answer by unpausing the video. Great, so you finished your question, and I hope the answer is correct. Alright, it's a simple answer and a simple way to solve. We start reading. 500 milliliters of a gas is collected. So they said that we collected 500 milliliters of gas. So that's going to be the clue for the first unit that for the first symbol that we're going to use, which is going to be for V1. So V1, the volume is going to be 500 milliliters. Okay, collected at 745.0 millimeters of mercury, which is going to be the pressure. I'm going to write down 745.0 millimeters of mercury, and that's going equal to, it says here, what will the volume be? So that means we're searching for volume. So P is known, and if the pressure becomes 900.0 millimeters of mercury, that's great, multiplied by the unknown volume, which is going to be written as V2. Alright, great. Alright, so when we start solving right now, we need to leave V2 on the side. We're going to do that algebraic expression by dividing 900 millimeters of mercury on both sides. What we're going to notice here is that we're going to have here the answer. V2 will equal to, let's do the math on the calculator. Alright, that's going to be great. The question is going to be 745.0 multiplied by 500 divided by 900.0. The answer is going to be for for that question. Let me just check if I did the math right. Yep, 700. Oh, all right, great. Calculator misplaced the number. Great. Okay, 745, and the answer is going to be 413. Just a second. 413.8. What is going to be the unit? Cancelling this and this. We're leaving with milliliters. That's going to be the new volume. All right. So that's for that question. All right. So let's go for our last question. Or let's delete that so we can have space. We want to have some space. So let's say a gas occupies 13 liters. Alright, at 1 ATM pressure. So there's 1 ATM pressure. What will be the pressure if the volume becomes 17.0 liters? Great, the last question is going to be a simple question, and I hope you guys solve it correctly. Alright, so let's start solving. I'll give you time. I'll read it for you, and you can pause the video and start solving. Alright, a gas occupies 13 liters. We can say 13.0 liters. At 1 ATM, what will be the pressure if the volume becomes 17.0 liters? Take your time, pause the video, and start solving. Great! So you solved the question. I hope you answered it correctly. Alright, so the question says, and let's answer it and check your answer. The question says that a gas occupies 3.0 liters. So that's the first clue for our answer. It says that it occupies 3.0 liters. So that means the V1 is going to be 13.0 liters, not 13.0 liters. Now that's going to be V1 at 1 ATM. So that's going to be the pressure, 1 ATM. So we're going to write down 1 ATM. Great. Alright, so what will be the pressure? So the question states that we don't know the pressure. So what do? We simply write P2 instead. Great. Multiply that by the volume, the new volume, which is going to be 17.0 liters. Nice. Let's solve that algebraic expression. 17.0 liters divided by 17.0 liters in both sides. We're going to have P2 left. So write P2 down and we write equal here. Liters cancels liters out and we're left with ATM, which is going to be a really simple question. Alright, so what's going to happen is that we're going to write 1 times 13.0 divided by 17.0, and that's going to give us an answer of 0.764 ATM. Great, so let me rewrite that again. It's going to be 0.64 ATM That's going to be P2. That's the answer. Our last answer is this. Alright, so we noticed that we started with 13 liters, the volume, and we increased the volume. So as we increase volume, pressure decreases. And that is really simple. Alright, that's a bonus question for all of you who's still thinking that they still didn't understand the question, and for the people who think that they actually understood the idea. Well, both of you, hard luck and good luck for the next questions. We're going to go for medium level of solving Boyle's law. Let me give you the bonus question, and I hope you guys all answer on the comment section what is the final answer, and I'm going to reply by either yes or no for the correct answer. If it's correct, I'm going to write yes. If it's not correct, I'm going to put no and give you the correct answer. Alright, so the last question states that we have 15.0 liters at 280 amp pressure, and then the new volume is going to be, or the V2 is going to be 20.0 liters. And I would like you guys just to solve the question. Alright, so when you solve that question, just write down the answer in the comment section, and yeah, I'll just check your answers and correct the ones that are wrong. Alright, before we end this lesson, I hope you guys enjoyed the video, and I just want to note out that in my channel, AP Chemistry Course, I have made an Instagram account. It's going to be called AP underscore chemistry underscore course 07. That's my Instagram, and in this Instagram I'm going to upload chemical reactions and mostly pictures of some elements of the periodic table that I own in my house. One more thing, that in the account I'm going to show the chemical reactions that I usually do at the house with precautions, and give some we're going to give the steps of how to solve how to make that chemical reaction occur. Alright, so this is all about our lesson for today, and I hope it is useful. If you're trying to solve also more questions about the ideal gas law, you can check out the link down in the description. I'm going to put a link for a drop quiz that I made, and I hope you guys just pass the quiz, and it's going to be really fun, and see you in the next video. Have a nice day.